Hi students, now I will be solving this particular problem, which is nothing but integration of x squared plus 1 divided by x plus 1 whole square into dx. Alright, so here what we will be substituting. Now if while substituting, okay, this thing is that after substituting this denominator, you won't directly get the numerator here, okay? So we are actually substituting this particular problem so that the problem gets more simplified. We will then do some direct mathematical manipulation and we will directly arrive at our answer. So what is the first thing that we have to do here? The first thing is that we will first consider let x plus 1 equal to t. If I do that, what will I be getting? Dx equal to dt. Right? Now, as we come here, now I hope you understood the what's the derivative of x plus 1. It is nothing but, in case of x, it is just dx, and in case of 1, it is 0, as 1 is a constant. Now, where do we go? The next point is that we have to simply substitute. So we can write this particular integration as x square plus 1 is written in the numerator, right? I will replace this x. Now x plus 1 is t. That is what we have considered, right? I can replace x as t minus 1. And that is exactly what I'll be doing here. In the place of x square plus 1, I'll be substituting only this x part by t minus 1. Rest all will stay as it is. And in the denominator, as we already know, x plus 1 is nothing but t, that is we have considered. That is why I have written it here. And at the same time, dx I have written as dt. We have got it here. Okay. So till this part, there is no issue. Now we will be simply solving it. Now if you break the upper part, what will you be getting? T square minus 2t plus 1. A minus b whole square formula is nothing but a square plus b square minus 2ab, right? And we get a plus 1 here from here, okay? And then we have t square in the denominator. Next, what we will be getting here in the numerator? We will be getting t square minus 2t plus 2 divided by t square into dt. Alright. Now we will separately divide this t square by t square and then by 2t and then by 2. So what we will be getting? T square divided by t square is nothing but 1. Minus of 2t by t square is nothing but minus of 2 by t plus 2 by t square into dt. Alright, what next? Now the integration of this thing is very simple. The integration of 1 dt is nothing but what? T, right? And the integration of minus 2 by t, it is nothing but minus 2 will come outside. 1 by t integration is nothing but log of mod t, okay? And the integration of 2 into t to the power minus 2, right, is nothing but 2 will come outside of the integration. T square I can write as t to the power minus 2. So t to the power minus 2 plus 1 in the numerator, which is nothing but minus 1 divided by minus 1 in the denominator, plus c. Now we will be doing a fair bit of simplification so that the problem looks a bit neat. So here, okay, I'll write this as t will be replaced by what? It will be replaced by x plus 1. So I'll write x plus 1 here, and here t will be replaced by x plus 1 again, and then here minus will come here, so this will become 2 by t, which is nothing but 2 by x plus 1 plus c. Okay, now in some explanations, or in if you take up some references, okay, you might find that the answer that they have written is like this. They have written all the things in the expression, but they have the 1 suddenly vanishes and the c gets replaced by c dash. Now why do they actually do that is because, you know, whenever you have more than one constant, like whenever you have more than anything other than the constant c, then they try to club those constants together. Okay, so here we had the constant c, and apart from that we also have a constant 1. I hope you know 1 is a constant number. Any number 2, 3, 4, whatever is written here, okay, that actually is considered as a constant. So whenever in any kind of references you find the solution to be written like this, where the 1 vanishes and the c becomes c dash, which means that c plus 1 is entirely clubbed in this c dash. Okay, because just to make the problem look complete and definite and more accurate, this thing is done. Okay, so now we will be moving on to the next problem. I hope you understood the problem clearly. Okay, now the next problem, this one is also very easy, and the problem looks easy also, it is not complicated. Okay, this is the particular problem. Now as we have no other option in mind as of now, so the first thing that we will be doing is simply we will consider a plus bx as t, and then I'll write this in the format of x actually. So I'll be getting t minus a into 1 by b. Okay, a goes on the right hand side, b comes in the denominator side, and now I'll be taking the derivative. So this part is a constant, so this part will entirely go away, so we are only left with 1 by b into t. So 1 by b remains as it is, and t becomes nothing but dt. Okay, so this is what we get. Now how shall we solve this particular problem? Simply the first task will be to replace. So we will replace the numerator by 1 by b square, t minus a whole square, as in the numerator we have x square, and in the denominator we will only be left with this part. And also in the place of dx we will be having 1 by b into dt. Now solving all of this, we will have a 1 by this b and this b. Okay, this b square actually comes in the denominator, so we will be having 1 by b cube in the outside, and on the inside we will be taking we will break this form, a minus b whole square form. So we will get t square minus 2at plus a square, right? And in the denominator what we will be getting? We are already having t square into dt. Alright, now what next? As I told you, whenever you have this format, just simply divide t square with all of these terms. So what will you be getting in that case? In that case, in the integration format, what you will be getting is t square by t square is 1. This will become 2a by t, plus this will become a square by t square, and then dt. Okay, now let's solve the integration part. If I solve the integration part, what will I be getting? 1 by b cube will be as it is. The integration of 1 dt is nothing but t. The integration of minus 2a by t is nothing but minus 2a will be on the outside, and this will be log of mod t. And the integration of a square by t square into dt is nothing but a square will come as a constant on the outside, and again we have t square, right? So we will write it as t to the power minus 2 in the numerator. So we will be having t to the power minus 1 by minus 1 plus c. As soon as we finish our integration, what is the next step that we will be following? Simply replacing that particular t. So if I replace t, I'll be getting a plus bx first, okay, minus 2a log mod of t, right? So we will be having mod of a plus bx minus a square will remain as it is. This minus actually came here, and t inverse, as I told you, can be written as 1 by t. So in the denominator we will be having a plus bx. Alright, close the bracket and we will be having a plus c. So these are the two problems that I wanted to solve for you, okay? I hope the problem is very clear to you. A new thing for you to learn here was, I think, this part, that you have to club the constants together in case you have any constant other than c. In case of this problem, other than c, we had the constant 1. So we actually clubbed both of these constants and considered as c dash. So c dash here is nothing but c plus 1, okay? So I hope this particular problem is clear to you, these two problems that I showed you. Integration can only be mastered by practice. Why integration? All the subjects, no matter whatever the exam is, it is very important for you to master the problems. To be in order to be able to master the problems, you will have to have a lot of practice, okay? Without practice, you cannot, attain that level of efficiency. No matter how big the exam is, the only one thing that is often told to the students is to practice, but not aimlessly practicing. Understanding each and every step of the problem, because whilst you are applying, if you consistently see the solution, then there is no use of practicing, okay? There are students also who practice a lot, but still they fail to achieve anything in competitive examination. This is why it is very important for you to analyze the problem. And in order to reach that level where you can do that analysis, you have to first understand the very fundamentals. Don't try to mug up these stuffs. Don't try to ask your friends that, what is common in the exam, what is the pattern and this and that. Try to be very forward with mathematics. Don't ask such silly questions that, what's the pattern? How should I go about this entire thing? What are the chances of getting this particular question? These shouldn't be your question, okay? You should be so good at math that no matter whatever question is put in front of you, you are able to confront it confidently without any confusion, okay? If you like my video, then please do like, share, subscribe, and do not forget to hit the notification bell icon for more of such exciting content, okay? I'm trying to be, in terms of teaching, I'm trying to simplify each and every problem as much as possible so that you can get the grip of how things are coming, how is it going, how can you solve different kinds of problems, okay? These are the things that took a lot of time when I used to be in 12th grade, okay? Because there wasn't any support actually at all. So I had to figure all of these things out by myself, and whilst at college, I had actually probably done a lot of math, which helped me learn many things and which I would love to share with you, okay? So now that we have come here, there are still many more problems to solve. Integration is actually a pretty big chapter. You have indefinite integration, which we are doing now, all right? And then we will be having definite integrals, okay, which is another chapter, all right? So these two things are really, really big. So this is why I thought of starting something new, maybe trigonometry next, okay, so that we can move in two directions at the same time. Because in case of trigonometry, there are a lot of concepts which students don't know. They mug up that sine 90 plus what is sine 90 minus theta cos theta. But why is it cos theta? Why do we write it as cos theta? When do we write it as cos theta? Those things should be clear to you, because the angles in trigonometry, okay, the concept of trigonometry is so important that be it electrical engineering or be it mechanical engineering, you will find endless usage. All right. So you have to be very particular with the kind of concepts that you are able to grip. Even in physics also, those students who major in physics, they also require concepts in trigonometry. It's well understood because everything is based on geometry, right? And so whatever things are based on geometry, it's essential that they also have angular stuffs, right? They have angular stuffs. So whenever angular stuffs come, trigonometry does get involved, okay? Try not to mug up maths, okay? In my lifetime, I have seen students doing that, and I find it pretty, I must say it's not something which is very good, okay? It's strange that students mug up math. It's not a good thing, okay? It only leads you to more and more confusion, because what you mug up is something that you remember only up till the exams, right? After that, you again forget. So what's the point, okay? Apart from grades, remember that there is something which is very important, that is concepts. So don't just mug up, all right? I think this is why I'm explaining you all these problems this much. If you can mug up, then you can take a book and simply mug up, right? That's not a big issue. But understanding each and every step, being able to solve different kinds of problems from the knowledge that I give you, that is where you win. In that case, if you get 2 or 3 marks less or 5 marks or 10 marks less, that's not a problem. But at least something goes inside of you, right? Because there are many students who really secure exceptional grades, but they fall out on concepts, okay? So I don't want you to be one of them. I want you to excel not only in grades, because grades are just numbers at the end, okay? I want you to excel in all the concepts as well, so that irrespective of how difficult a problem is, you are able to approach it. That should be your level of confidence, and that is exactly the destination that I want you to reach, and that is exactly what I'm working for. All right, so a lot of talk. Now let's move on to the next video.